Tonight's Open Circuit, IEEE UCF's new official podcast. My name is Brian.
And I'm Fernando. On today's episode, we have Dr. Reza Abdolvand. He's an associate professor in the Department of Electrical and Computer Engineering at UCF. He leads a research group called Dynamic Microsystems Lab that has over 80 publications and is well renowned in the thin film piezo resistor community.
Piezoelectric.
Piezoelectric.
Additionally, Professor Abdolvand teaches Circuits 1 and 2, Electronics 1 and 2, Introduction to Micro-electro-mechanical Systems, MEMS, Introduction to Sensors, and 2 graduate courses on microfabrication. He is the recipient of the 2019 UCF Teaching Incentive Award and is the recipient of the 2018 College of Engineering Excellence and Undergraduate Teaching Award. So wow, as an undergraduate researcher, something that really stands out to me in this introduction is 80 publications. That's
quite a feat. That's a lot.
Did you realize, the first time you're going into research, writing your first paper, that it would come this far?
Everyone, let me just get a minute to thank you, all of you, for your invitation. From what I understand, this is actually a new thing that you're trying to do. So this is quite an honor to be your first guest. Appreciate it, and I think that this is actually a pretty good thing to do. I feel like in the past I felt like there are more that the students at our department can do to kind of create a more lively environment for everyone. This could be, and there's a lot that you can do in this domain. I don't know where this idea is coming from, but I assume COVID has had something to do with it, and that's good. This pandemic has made all of us think about doing things differently and maybe sometimes better and more efficient and more basically useful. So let me get to your question then. So publication. So in our line of work, when you work for a research institution, and that's what UCF is, publication is actually a major. It's how a lot of people look at your work and basically say they rate how you do, basically. So it's expected of any good researcher to publish their work. But beyond that, quite honestly, I think it should be important for anyone that does anything new to basically let everyone else to know about what they're doing. And I never thought how many publications I'm going to have, but I think I could have had a lot more if I focused on publication. But more to me, quality of what I publish is more important. So I'm actually being selective. And in our world, publishing at least like 5 to 10 conference papers and say 3 to 4 journal papers per year is nothing unusual. So I expect that to keep being the modality of my operation, and I hope more than the numbers, really people are going to judge us based on the material that we publish, the quality of what we publish. Some of our publication has, I think, been quite well received by our community, and I hope that we continue publishing more of that kind of that caliber of papers. Did I answer your question?
Yes.
I think so. And of course, thank you so much for being here on this inaugural show.
And of course, like you stated before, how Corona, made this happen in a way. How's Corona affected you, your research, and being a professor overall?
So, great question. I mean, Corona has had like this pandemic has had a lot of different ways of affecting our operation. Now, there are certain kind of work that could be done completely remotely. Like if there are researchers that work on basically coding and theoretical analysis, and what they need to do is mostly could be done on computers. And for them, I've heard in some circles that they're actually doing better compared to
wow.
yeah. So, but in my line of work, when we're doing experimental research, for the first few months, we really couldn't do much other than just writing some papers, kind of write on the residue of what we had accomplished in the past in terms of generating data, and just use that data to publish, and maybe basically just let the community know about more of what we have done in the past.
Yeah.
But at some point that can't be enough. Like you have to create new information and new data, and we had to come back to the lab. Fortunately, at that period of time, then UCF started reopening some of the labs. So starting, I want to say around June, we started coming back to campus at a limited capacity, and we have been doing the same until now. It hasn't been really easy on us, the experimental researchers. But I think we're going to survive. It's all right. We're still making progress. We have received some new funding, and I think it's going to be all right. It's definitely harder on my students, my PhD students and researchers in the lab, because they are actually the people that need to make as much progress as they could, and kind of publish the result and get their degrees and finish. But I think everyone is affected the same way, and everyone is understanding. So everyone's trying to help and be flexible as they could. In terms of teaching, I don't know. It's a mixed bag. So there are aspects of it that are good, I actually think. Mm-hmm. And I think that I've shared this with you in the past, that there are certain things in terms of the modality, the new modality that we use, Zoom and all that, that are better. And if the time basically gives us, well, if we can talk about it, I'll let you know more about those aspects if the questions come up.
Mm-hmm.
All right. Yeah, and I mean, it seems like if someone's passionate enough, they're going to be able to figure out the situation as best as they can. And it definitely seems like you're passionate about your research. Although I've never had you as a professor, it also seems like you're definitely a passionate professor as well. But I haven't been able to experience that firsthand.
I would love to have you. You still have time. How long are you going to be here?
I'm probably going to be here for about another year. And then I'll be.
Yeah, so there are a couple of courses that I teach in a senior level, so look for those.
I've actually been I've been blessed enough to have you as a professor, and something that I really did appreciate about you was the videos that you did before like Corona even happened.
Oh, so you took the course last fall with me? Mm-hmm. Is that right?
Yes.
Was that last fall?
I believe so. It was last fall.
Yeah, it's because that's just kind of the time frame that I started using those videos.
Oh, really?
Yeah. So last summer, not this summer, this past summer, the summer before, it's like summer 2019 mm-hmm. was the first test run. Kind of started testing those videos, and then in fall of 2019 was the first time that I actually used those in a class as teaching material. And so,
would you consider yourself like the Christopher Columbus of like online learning?
Oh no, by no means. I mean, what I was trying to do was nothing new. Even in our department, there are other professors that have tried this. I don't know if you know Dr. Demara. So he actually kind of introduced me to this kind of activities and trying to use this medium, I mean the virtual class medium, and definitely owe it to him. And he's doing that for some computer architecture courses, I think, and he's doing great. But really, the thought of trying different things, like new ways of teaching and kind of taking advantage of what's available now that wasn't before, has been with me for quite a long time. I think we are not taking, as the whole community, like the community of people that are trying to teach. I'm not limiting it even to colleges or universities. Anyone who tries to teach someone something. I think we are not taking advantage of what technology has given us to an extent that we could. Obviously, it takes time and it takes some flexibility, but we can definitely do more. And based on that curiosity in me, then I was introduced this through Dr. Dubara, and then I took courses at UCF for basically preparing videos for courses, and then the whole thing started like that, which then coincidentally the COVID-19 happened, and it just made it really useful at that point. If no one knows, they could actually kind of read into it as if I knew what's going to happen, because the timing was kind of perfect, worked perfect for me. But generally speaking, I think this is the direction that everything is going to move from now on. And things are going to go back. There's a lot that could be gained by doing things virtually. There are aspects of teaching that still has to be person to person, and that's going to stay, but there are definitely aspects of it that could and should be done virtually. It's useful for both students and teachers to do it that way.
Oh yeah.
No, absolutely.
I'm definitely a more, kinesthetic, hands-on person, but being able to not have to leave the comfort of my home to, gain theory, gain knowledge, and do all of that has been really nice the last few months. Obviously, I wish the circumstances could have been a little better, a little bit different, but the fact that we're moving to online has simply, it seems like it's been very beneficial to a wide variety of people.
There are like now that we had to move, like we were pushed. So, and a lot of times they say the mother of invention is necessity. So when you need something, then you're going to make adjustments and create something new. And a lot of times through this process, now we can actually start thinking about what holes needs to be filled. Because there are aspects of it that are not good, but they can be actually improved too. Like, for example, I'll give you an example. Testing is still a big issue. Like, how do you evaluate people? And we don't have really good solutions for it. But I think over time, things are going to change to an extent that we can just adopt new ways of evaluating people that are fair to everyone and are basically traceable and all that kind of stuff.
No, absolutely. I know personally, from a student's perspective, the one huge benefit for me has been studying, because I can go back to the lectures, pause it, and I can look at how he or she wrote the equation, or just review everything in a better manner.
Absolutely.
Oh yeah.
As soon as I started using this material, obviously I kept asking for feedback from students, and one feedback that was recurring pretty much in every comment that I received was that the advantage of doing lectures online is that I can go back to it and watch it anytime I want, however many time I want. I can stop it, take notes, go back, re-listen, and that doesn't exist in a normal lecture at all. So you have to take notes right away, and there are a lot of people that they say when they take note, they can't listen, they can't comprehend, they can't do both at the same time. I was like that when I was a student, and that's why I never took any notes.
So we've seen we've seen a lot of these, these different approaches coming online. And like you said, there have been problems with testing certain things. I mean, like I said, someone like me, I'm very kinesthetic. I love my hands-on material. So not having lab has actually been quite a detriment. But, having lectures are quite incredible. Moving forward as a professor, when this whole COVID situation is finally calmed down, what do you see as the ideal teaching environment for students, at least from your perspective?
So until we can do a fully virtual lab, which I think is going to happen, it's in the horizon. Like I think in 5 to 10 years, we're going to have completely virtual labs. Like I'm thinking, this is just a crazy idea, but I think there's going to be a time where you put on your 3D glasses and then you put on your 3D gloves, and then you enter a virtual lab and you actually do the experiment, but the whole medium is virtual. Like everything is simulated. So you get to actually do the experiment, take your resistor, put it in a breadboard, but everything is virtual. I think that's going to happen. Now, how much value is that, or what kind of problems that's going to cause, I don't know. But I think there's going to be a move in that direction because of all the advantages of it. It's a lot less costly. Once you have to put in a lot of effort in order to develop that system. But once you do that, you don't need any equipment. You don't need any actual physical lab. And I think it's going to happen. There are going to be fully virtual universities in the future. Again, I don't know how good or what the problems with that going to be. But anyway, and now with that said, I think for now there are aspects of teaching that has to stay in person, like especially in engineering labs. For now, they have to be in person. I mean, and really, labs to me are the place where you make mistakes. Where you go in and try to accomplish something, and then you mess it up, and then from that you gain some intuitive understanding of what works and what doesn't work, and if it works, why does it work, and if it doesn't work, why doesn't it? And that aspect of it right now can't be replicated in any shape or form virtually. But the component that definitely should stay online are the lectures. Like, I think it doesn't make sense. I mean, it hasn't made sense for actually quite some time, I think, for the people to just all come together in one room and listen to someone basically, for the most part, read a book to them. That doesn't make sense. Like, why would you do that? First of all, if you want to just read the book yourself.
Yeah.
You don't need me to read the book to you.
We
Especially,
usually
I'm
have the
talking
book
about
at
like
home.
these, like there are certain classes, and I don't want to be specific, but I think you can relate to that, like, for example, the instructor is going to show you a bunch of figures or pictures or statements from a book on a presentation, and just basically he or she is reading that to you, which is coming from a book, I assume. So why are we doing that?
Oh yeah.
And I'm not saying that is wrong or needs to be changed in any way. I'm just saying we don't need to do that in a certain class, people coming together. You can just do the same thing, put it online, and people watch it. Or there are, I can think of, especially disciplines other than engineering, that a lot of what they do is just basically reciting material that are in books.
Yeah.
And for those, I don't see much of a reason why you can't just put those online. I think the only reason that class in its traditional form, this still has some functionality, is if I come in and I tell you something that is not in any book, or I interact with you in a way that you can't comprehend material just reading a book, which means I have to have something that I can add that is of value as an instructor. And to me, that could be my experiences. Like as an individual, I hope I have experiences that are of value to you. And I just come to class and I share those kind of perspectives and with you, and whether or not it's gonna be useful to you, it's a personal thing. Maybe it's useful to someone and not as useful to someone else. And the other thing that we can do is to practice interacting with each other. Like that just that on its own has some value. Just asking questions, discussing, arguing about stuff, material. That's an aspect that I think has value, and it helps us grow as people and as engineers. And that still needs to be done in a modality where a group of people get together and face to face and kind of argue about things. And maybe at times I can hold your hand doing something. Actually, I don't know, like I ask you to present something in front of everyone else, and then I start kind of criticizing what you're doing, and everyone else jumps in and criticizes you or defends you, kind of a discussion environment. And I think at some point, again, this kind of activity could also be done virtually. But at least right now, I think it's still better to keep it live and person to person. It just have a better feel to it at the moment.
That makes sense.
Yeah.
No, yeah, of course. But with this being said, I was just going to throw like an honest question. How do you think your students see you as a professor?
I get a lot of feedback from, like, I always solicit feedback, both the formal feedback that students give me, and I go beyond that. And if in any opportunity that I have, I ask people to give me feedback. And the reason is that I don't like to repeat myself ever. Like, I always want to do something different every time that I do it, because I think there are always things that could be done better. And that's why I always care about listening to what they have to say. On average, people like the way that I teach, and there are aspects that I care about, and I convey that in terms of teaching, in terms of how I emphasize certain parts of certain things in my class, or how I don't care about certain other things. There are a lot of people that like the way that I approach presenting the material that I teach, but there's always people that don't like it, actually. So I want to say about 60 to 70% really like how I do things. About 20, maybe to 25% are not are okay. Like, they don't think it's anything special. They're just doing fine and they're good with me in class. And there are about 5 to 10% that they don't like it. It just doesn't connect with them. And to me, the most important portion of this distribution that I talked to you about is that 5 to 10%. I really want to hear from them, and I want to listen to them and see what it is that they don't like about it. I'll give you an example. Like, one thing that I know, and I've heard that, is that I always encourage people to ask questions, but there's a certain percentage in my class, always, like at least a few, that they don't like how I answer those questions. Like, I say, the way you say ask questions, but when we do ask questions, you don't treat the question well. You don't, like, your treatment of the question is not encouraging. So, and I'm sensitive about that. I try to figure out what it is that I do that might discourage people from asking questions. And there's some things that you like. It doesn't matter how consciously I like people to ask questions. It's quite possible, actually I'm 100% sure it is possible, that unconsciously I do things that may discourage people, and I have to be sensitive about it and look for it. But on average, I think the students generally are happy with the way that things are done in my class.
No, of course.
Yeah,
Go ahead. I'm sorry.
I was going to say, yeah, that sounds absolutely incredible. I know from my perspective, whether or not the information is being perfectly translated, my concept of a good professor is whether or not you want to be there and if you care about the students that you're teaching. Obviously, from the student's perspective, that may be misconstrued just by, like you said, subconscious things that may not be quite exactly what you're intending. But hearing that you care so much about, 70% might enjoy what you're doing, but that 5% is what really matters, I think is extremely incredible and really impressive from a teaching standpoint. Do you feel though that those criticisms are ever going to go away? Do you feel like you're ever going to like hit that pinnacle of, professional, incredible teacher or professor?
No, it's not possible. I don't think I'm going to reach it. Like, because the classes at UCF are big. Like, if I had 15 people in a class, then I could kind of see a future where I really tender each one of them, like tend to each one. Like, say, okay, do you like this way? I'm going to do it this way for you. How about you? Do you want me to do this? Then I'm going to, like, no, I could see that if the class was small. But since the classes are huge at UCF, it's 75 people in one class, I can't tend to all of them. There's no way. But what I'm saying is that there are things about those interactions that are not good with that 5%. Yes, I didn't mean to hurt them, or I didn't mean to just basically create an environment that they don't enjoy, but that has happened. Now that it has happened, what I can do about it is to understand what went wrong and maybe fine-tune something that 5% becomes, I don't know, 4.8%. That's an improvement.
Oh, yeah.
So,
oh, yeah, that's
so
awesome.
If there are things that I can do, but I don't think that there's a time that I'm going to teach a class, 75 people in a class, where everyone is happy. It's quite impossible. It would be a fluke even if it happens.
I still think that, like, the matter of the fact that you're trying to improve that 5% just says so much about you. Because I know I have like professors X, I won't say names, but Professor X, they have 20%, like 30%, and it's a sad reality that most professors don't really show as much passion as you would. So when you were in undergrad, is this the reason why you teach the way you did? Because you want to be better than the people that taught you, or is there something that influenced your teaching style?
Where's my influence coming from? I actually, I think, first of all, I actually come from a lineage of teachers.
Oh.
My dad and my mom, they were both teachers. So
that's awesome.
So
Whoa.
Yeah. So runs in the family.
I had some in my blood, I guess. But quite honestly, I never wanted to be a professor. So that was not really my dream job. It's not like I was always dreaming to become a professor. And I didn't have really plans for it either. But I can tell you I was a good student. So, like, throughout all the years that I was a student, I was always a really good student. At least trying to be a really good student. And one of the aspects of being a good student, to me, is to study the instructor. Like, I always actually look, like, I don't only study the material, I also study the instructor. That's actually quite fun, what used to be quite fun to me. So I analyze the people that they teach me, and I've learned a lot from every one of them. Every one of them have had something quite unique that has taught me, especially like I'm not talking about really good teachers. Even the people that they don't do good, they have a lot to teach you. Like, what it is that you don't like about that person, like it doesn't connect, and you say, I think I shouldn't do this. That's not what I want to do. So yeah,
That's awesome. It
Yeah,
sounds like you're
so
quite
I've
astute.
learned, I think, that I can't tell you like the way that I approach teaching is coming from a single person in the past, in my past, but like anything else, I can trace influence of maybe each one of them in me, starting from my like really early on teachers in I don't know, in middle school and even before. Like,
Oh,
okay,
wow.
there, I'll tell you one thing. My first grade teacher was my mom.
Oh,
So her influence is definitely with me. Anyways,
learn young. Did you so where was that turning point then? Where was that turning point where you're like, all right, I'm gonna be a professor now?
so so things. Okay, so here I tell you a little bit more about myself. I'm not a great planner. I've never been. I'm still not a great planner. Like I don't have. Well, let me correct myself. Like you see people that they really plan everything. Like they plan their day, they plan their week, then they plan their month, then and they plan all their moves. Like they know exactly what's going to happen at what point in their life and what exactly they want to happen. I'm not like that. I actually don't operate based on that. And I'm not criticizing anyone who does or doesn't. I'm just telling you who I am.
Yeah, everyone lives their own style.
Yeah. So the way that I operate is that I usually have like a few big goals. Like I kind of aspire to a few big goals, and those are the ones that I want to happen. But even for those, I don't have a set timeline. I just know that I want these things. And then the rest is completely flexible. Like I don't really plan anything else in between. So usually prioritize a few things and then just go for them. And so becoming a professor was quite a journey. Like I really didn't have a plan to become a professor. And I can tell you exactly what happened. So I don't know if you guys know, but my wife is a professor. My wife is actually Dr. Ranavar. She is in our department. So at the time that, and her and I, so Dr. Ranavar and I, we go back for many, many years. Like now I know her for, I don't know, definitely more than half of my life, like 25
Wow.
years.
That's awesome. Wow.
Yeah.
Yeah.
But
No, that's amazing.
So at when we were doing PhD, we got married when we were doing our PhD at Georgia Tech together.
Oh.
And she always wanted to become a professor. Like she's actually a better planner than I am in that sense. That she have more specific planning skills in terms of when and how she wants things to happen. And then when we finished our PhD, she really wanted to become a professor, and the kind of job offers that she received at the time were in places that I couldn't do much other than becoming a professor. so then I kind of went with the flow, and I just chose to become a professor too, in order to be together. That's how it happened, really, quite honestly. Like it wasn't planned at all. But I tell you one thing, it comes with the way I treat my life, like how I operate, is that I don't put a lot of emphasis on exactly what I do and how things happen in my life. But whatever it is that I do, I'll try to do the best that I can do. So once I became a professor, then it was my goal and an aspiration to be the best professor that I could be. So, and that's how I treat, quite honestly, anything else in my life. I really take things that I do seriously. It becomes a challenge for me to really do the best that I can do in anything that I do.
That's awesome. That is really awesome.
Yeah, so that was the story of how I became a professor. I don't think that was what you expected.
That is not at all what I
No.
expected. But I was really happy to hear. And it's so incredible that you met your wife through this whole profession as well. Like that's
Yes, so I met my wife, Dr. Ranavert, when I was 18 years old, when I entered college.
wow.
Wow.
Well, congratulations. That's so nice. And it's also refreshing to hear, I feel like when we are, freshmen coming into college and we have these courses that talk to you about time management. And I even at one point was recommended to plan out my entire month. And that was just something that never clicked, and to some extent, when you're being told, like, plan your entire month, you got to know exactly what you're doing, and you don't do it, it doesn't make you feel all that great. So seeing someone like you who is well liked, who is a great professor, saying, I don't plan everything, that's wonderful to hear.
Brian, I have to be careful here. I don't want to be responsible for your future failures.
I plan. It's just, a little bit down the week, not the month.
Yeah, one thing I can tell you, I think there's definitely value in planning things. There's definitely value. But one thing I'm sure of is that not everyone operates the same way. Meaning that one thing that is good for you, it's not necessarily good for everyone. Like there are people that wouldn't operate as well as they are if they don't plan. But if you then take that model and say, okay, now everyone has to plan the same way, it's actually going to kill me. I know for that. Like, if you plan every one of my moves, I'm going to feel imprisoned. Like, I just don't feel good about that.
Oh yeah, and that's part of the reason why I loved UCF so much. I mean, when I came here, the entire orientation was, about diversity, about celebrating the student. It didn't seem like that expectation was being placed, and that was my biggest selling point is, I'm not going to be told exactly what I should be doing. I'm going to, take the power of a diverse individual and use that to my advantage so I can be the most successful. Obviously, while helping others along the way. I don't mean that in a very individualistic mindset, but more just the understanding to be successful isn't an overarching umbrella that everyone has to follow to a specific routine.
That definitely has been my experience, that there are many different ways of being successful. Success is a very personal thing.
No, of course. But while we're on the topic of success and you trying to be the best at whichever thing that you want to do, what was one of your biggest failures as a teacher? Or what was your biggest learning experience from being a teacher so far, from the beginning to now, being a beloved professor by many students?
Oh, that's a good question. So, see, I don't think I can kind of characterize the state that I am in by one big failure. But I can definitely tell you that I'm shaped by my failures. Like, it's a more gradual thing. First time I started teaching, and I started actually teaching circuits and electronics. Those were the first courses that I started to teach. And I always was a really good student, and I really knew how to do circuit analysis. That was my bread and butter. Like, I was really good. So I was quite confident that, okay, I know how to do circuit analysis. And I went in class and I started teaching, and I couldn't believe how badly things started going. Like, I bombed really bad. It was amazing to me that how someone could do so badly while I knew I can do it myself. And very quickly I understood, and this is a saying that everyone knows, if you really, like, a testament to whether or not you know something is to whether or not you can teach that thing. Like, if you want to test yourself, test your knowledge, in terms of whether or not you really know it, try to teach it to someone else. Then you know. And, and it hit me really hard the first time that I started to teach. And I really feel bad about those poor students in my first class. They were basically my guinea pigs. But I think I quickly adapted. Like I started like within the same semester. By the end of the semester, I was a much better teacher by the time that the things finished. But it wasn't a good semester for sure. I know for that.
Well, everyone's got to start somewhere.
Yeah, there's always bumps in the road.
Yeah. So yeah, definitely. And the things that I started thinking about what it is that causes that kind of failure. Why can't I? How is it that I know how to do something, but I can't clearly show it to someone else? And it hit me hard. I figured it out, and that's actually how how the whole. I don't know. You have seen me, Fernando, how I do things like this. The universal approach that I always preach in class. Okay. That's where it's coming from. It was fed through that failure. Because I felt like the reason I can't teach the material is that I don't have an algorithm for it. Like there is no systematic way that I do things myself. I just go at it. Like you give me a circuit problem, I do it. I can't tell you how. I can't tell you what's going on in my head. It's a complex thing that has like accumulated over years of practicing and doing circuits, but there's no algorithm for it. Like I can't tell you this is the first thing that I do and then this is the next thing that I do. I just do it, right? So then I kind of stepped back and said, okay, I need to do something about this. I need to develop an algorithm that I need to turn this approach of mine to something that could be algorithmic, a system. And in that system, then my real objective was universality. Like I wanted this to be applicable to everything that I do so that I don't change it every time that the question is changed. That's where this whole thing is coming from, Fernando. No, I'm talking to you specifically because Brian doesn't know about that. so yeah, Brian, the way I teach basically 4 of the courses that I teach is Circuit 1, Circuit 2, Electronics 1, Electronics 2. For any one of those problems, like I think about all these 4 courses and how many different problems I do in all of these problems. In all of them, I use exactly the same algorithm.
Really?
I would say it's really interesting because no professor has done it like that. It's always been like by the textbook way, you know?
Yeah. No,
and
there's no textbook does it the way that I do, and that is actually a problem. Like one of the problems that people sometimes tell me is exactly that. Like I use a textbook, right? But I really don't use that textbook because I'm doing it my way. And to people, sometimes that's confusing because, well, then why are you using a textbook if you're not using it really? So that's why one of my goals right now, one of those few goals that I told you about, is to write a textbook.
Oh,
that's
wow.
awesome. That sounds like a handful.
Yeah.
I don't know again, I'm not a good planner. I don't know when this is going to happen, but that's one of my goals.
It sounds like though when it does, you're going to put your heart and soul into it.
Yes, I'm actually doing it right now. Like for me, this is like so I'm writing a textbook here, right?
Yep.
Yeah, like I'm preparing for it.
Oh yeah, the whole marination period before you start diving in. That's awesome. Is there any insight to that algorithm, or is that like a classroom exclusive that I can't hear until I take your class?
It's actually on YouTube.
You can check out his YouTube in the link.
Yeah, all right. Yeah. We'll have that link below.
I call it the universal method, and quite honestly, it's not anything new. It's not like I invented a new way of doing this. It's not that at all. I just took whatever that is available and just turn it into a step-by-step process that you don't have to change every time and there's nothing special about it. It's just like turning into an algorithm that helps. And I've seen a lot of people liking that. Like a lot of students like to see that certainty that comes with just following steps.
Oh yeah, and I'm sure you all have heard, the idea that there's nothing new under the sun. But the people who are able to take what is not new and turn it into something that's more easily digestible for a larger audience are usually the ones, in my perspective, who are successful, especially in the realm of teaching and trying to translate information. So kudos to you, because I'm certain not everyone can do that.
Thank you.
No, of course. As a student too, it's really good seeing like different perspectives, like different approaches, and it's just so helpful having that like in your back pocket, just in case you need it, just whip it out anytime.
Yeah, exactly. So like in anything that you do, one sign of being good at what you do is the confidence that you have. Like when you feel you're good, then you become confident, and that actually makes you better. Like just the fact that you think you're good, it actually makes you better, right? So when you have that tool in your toolbox that you say, you know what, I think I can do any circuit analysis because I know this algorithm, right? And that makes you confident, and just by that, you become better.
Oh yeah. Although I would like, to clarify for those watching, it's important to, be confident in what you're doing, but also remember constructive criticism is worth listening to, which is something that you obviously exercise as well.
Yeah. But
you don't want to be overconfident.
Oh, absolutely. But with that being said, at one point you become confident, because I know like many students, even myself, we face like imposter syndrome, where we don't think we're good enough. We don't really know what's going on. But in reality, we do know what's going on. So was it after you graduated, got your doctorates? Like at what point did you realize, hey, I know what I'm doing. I'm an engineer. I'm an electrical engineer. I'm a doctor. I know all this.
Okay, that's a good question. So I think, again, this was a gradual thing. But if I want to tell you when I started feeling proud of what I have, or I felt like I'm bringing something to the table now, like I have something to present, it was actually during my undergrad. I started working for a company as an intern, and that experience really shaped me as an engineer. And that's why anytime I talk to any undergrad, I really advise them to do internships, and especially do internships with companies that challenge them. Like the company pushes them to do something beyond what they think they can do. And that's what exactly that company and that experience gave me. The day one I went in, and this is a true story. I was a second year electrical engineering student. All I knew was circuit 1, circuit 2, and a little bit of electronics. I went to that company, and I said, okay, who are you? I said, I'm this person, this is what I do, and this is how much I know. They said, okay, do you see this? They showed me a box. It was a product that they use in their work. I said, okay, go make this. that's how so they wanted me to build this product that they were using, but they wanted to build it so they don't have to actually buy it from a vendor, and instead they wanted that built in their company. And I said,
that's incredible. All right,
take this, go build it, and come back when you're done. And it was like the amount, like I felt like, wow, these people, I don't understand why they trust me, but they do. So I'm gonna show them that I'm worth their trust. So I took it really seriously, and I delivered, by the way. So
awesome.
I don't know how much it took me, but after a few months, I had that product, and I still think to date, they still have that product in that company. So when I finished that was when I felt, oh, I think I have something to give now. Like I can do things. That was kind of a switch for me when I felt, okay, I have something to present. I can add to things.
What an incredible experience! Did you
It
feel
was
that?
amazing. It was amazing, and that relationship went on for many years after that. And I ended up building a lot of other instruments for that company.
Very cool.
But it was quite an experience.
That is so cool. Did you have that confidence going into that first like job interview, or was that?
I think I was confident in terms of, because I told you I was always a good student, right?
Yeah.
So the material that I was taught, I was confident that, like, circuit 1, circuit 2, a little bit of electronics 1. If you had any question about those things, I was confident that I can answer those questions. But not to an extent that you show me an instrument and say, okay, go build this.
Oh, yeah.
Not that kind of confidence.
Oh, yeah.
So basically it was a reverse engineering problem. So there was a functional instrument that they wanted me to reverse engineer, kind of understand how it operates and then replicate that operation.
That's incredible. Is that something you'd recommend for anyone to do? Well, anyone within the field, obviously.
General advice is that start doing something that matters, so that then you take it really seriously. Like, okay, you do your homework, it's great, it's for a grade, you get a grade, you pass, you move on. If you don't do that homework, you're not going to do that grade, you get a B instead of an A, you still pass, it's all right. Someone tells you, hey, this project you're doing really depends on whether or not you can build this thing. That's a different feeling, right? You feel a different weight on you, and that's a really good feeling. Like growth, I tell you one thing: growth comes from accepting responsibility. Like you're given responsibility, you accept it, and you manage to deliver, you grow. Okay, so you should look for opportunities that you're put in that spot, that people trust to give you responsibilities, and you definitely should not say no. Okay, and so you go in, and if you're lucky enough that someone is trusting you with a real responsibility, say yes, take it really seriously, and deliver. And then you come out a different person. Like you go in a different person, come out a completely different person. And just keep repeating that. That's what you need to do in life. Just keep looking for opportunities where you are put in a place of accepting your responsibility, whatever that responsibility is. And it doesn't have to be professional necessarily. Life offers responsibility in any instance that you can think of.
That's awesome. And that's some powerful advice.
Absolutely.
It's definitely some powerful advice.
No, I know personally. Let's take back to my freshman year. I'm a senior now at UCF. I was a very shy kid, but it wasn't until I became an officer in a different club that I really came out of my shell, because I was forced to take on some responsibility.
Absolutely.
So to the viewers, I just want to say, get out there, do a project, join a team, just do what you can to better yourself. Not just for your resume, but just personal growth.
Absolutely.
Oh, yeah. Oh, yeah. And I know this is probably a little bit on left field here, but I actually do a lot of work in the music industry, and that whole thing started because somebody needed a piece of music done when I was 18, and I was like, I'll do it. And jumped into my first business meeting, talked to some people, and threw it together.
So generally, I think from this discussion, we can all see that how accepting responsibility results in growth if you take that responsibility seriously. And
Oh yeah.
I can tell you one of the reasons that people sometimes shy away from responsibility is that they are afraid of failure. Like we all are afraid of that. I'm not saying there's some of us who are
No,
afraid
of
of it.
course.
Everyone is afraid of failure. But you have to
yeah.
accept that risk. Like that's a sign of growth. You say, okay, there's a possibility that I'm going to fail, and it's all right. You're not planning for failure. You're going to plan for success. You're going to do the best you can in order to be successful. But then failure is part of being just active. Like as soon as you start doing something, there's a risk of failure, and you have to accept that. You're not
Oh.
taking it lightly. You're not saying whatever. You're going to go for success, but you accept the risk of failing, and that's part of the deal. You just have to accept it.
And although, your success being a big influence over someone else's success is an extremely pressuring and terrifying thing to go through, there's that secondary emotion that comes with it that really lights a fire inside of you. It is scary, and from the outside looking in, it's like, why would I do that if I don't know I can? But when you put yourself in that situation, it's like, oh, I can do this. I can make this happen. And if you take it seriously, you kind of do whatever it takes to make sure it's a successful outcome. But of course, failure is always an option.
Yeah, and
Always an
one thing I
option.
tell you is that as someone who then now I am in a position to give other people the opportunity to be responsible for something. I really, that experience that I told you back in the day when I started working, I think those people did me a huge favor that I won't ever be able to repay to them. But the only way that I can repay that is to now offer the same kind of opportunity to other people. Like say, okay, I'm going to trust you. Here, take it and do it. And at that moment, I am taking a risk too, because there's a pretty good chance that that person is going to fail. And with that failure comes my failure, right? Because that's my idea, that's my project, that's my line of work. And I'm putting my trust in someone else, assuming that they're going to be able to succeed. But most of the time they won't.
I think it's
And I'm
definitely a
fine
great
with that. I'm completely fine with
Yeah.
that, because I think I owe it to the people that trusted me to then give it to someone else.
Does it occur to you that you're kind of molding the future engineers of the world?
Oh,
You're like-
I that's my, oh, no, that's definitely what I'm going for here.
No,
Like
that's
intentional.
amazing.
That's one thing that I always think about. That's actually the way I feel my impact, the way I feel about my impact in the position that I am is through enabling people like you to become better people / engineers. Not just you, just like students in my
Yeah.
research group and everyone around me. That's my objective. That's how I feel about how I feel about what I'm doing. Like that's the goal I have in my mind. Every day I wake up and that's my goal. That's what I want to do. I want to make, like I see myself as an enabler right now. I want to enable you guys to become better people. That's how I see myself like that. That's why I want to write a book.
That's awesome. That sounds like the mark of a great professor.
Thank you.
No.
Hope so.
No, absolutely. Now, to stem away from this topic, let's say if time and money was an obstacle, would you still do the research you're doing, or would you move on to something else that you might be interested in?
Actually, I consider myself very fortunate and blessed in a sense that, for the most part, in terms of research, I've usually had enough to be able to pursue what interests me. So any project that I do in my group right now, I really like it. It's one thing that I have personal interest in doing it. But then I'm going to maybe reword your question a little bit. Is there anything that is there any extension of the things that I do right now that if I had a lot more money, I would really spend more time on? Yes, there are certain aspects of the research that I do that if I had more money, I would have spent more time and effort on it. I like for quite a while I've started developing an interest in the application of the things that I do in biosensing. So I like to use my knowledge to kind of be able to improve human health. So that's one of the things. Again, the reason is that I think that has the most immediate impact. I think I've reached a point in my life in terms of age and all that the thing that I care about most is impact. Like I don't know, this is grandiose, or at least sounds grandiose, but I'm at a point in my life that I think about legacy a lot. That's how I think about it, and I feel like that kind of application with biosensing and generally interface with human biology would have a real impact, or an immediate impact. So that's the kind of projects that I would like to do more if I get money. And I'm still trying, and we have already had some success, but it's not to an extent that I really wanted it to be right now. So I'm hoping that I'm going to be able to do more of that in the future. And then there's a more nerdy kind of a project or interest of mine that I would like to be able to do. And that's on the intersection of how electrons, photons, and phonons interact in a material. Like, that has always fascinated me. Like these quantum particles, photons, electrons, and phonons, they interact with each other. And at the intersect of their interaction, very interesting phenomenon happens. Like things that really puts a smile on my face. Like when I learn about them, I really feel good. I know it's very nerdy, and to most people, I'm gonna sound like a crazy person.
I mean, it just boggles the mind. There's like, I guess maybe not all our reviewers will understand, but when you get down to such a small level of particle physics, that things just don't operate the same way they do in regular Newtonian physics.
Yeah. So there's this phenomena, for example, that we're studying at the moment in my group, and that really fascinates me, and I'm really interested in doing more with that kind of experiments, is that acoustic waves. You know about acoustic waves, right? So we actually, in my group, we work on devices in which there are acoustic waves trapped. They're called acoustic resonators, right? And so we excite an acoustic wave in a substrate, usually made of silicon. And the wave travels, and then it carries energy with it. Now, there's this really interesting phenomena. It's called the piezoelectric phenomena, that you can cause the amplitude of this acoustic wave to increase by just passing a current through silicon. Like you pass a current through silicon, and the acoustic wave actually increases in amplitude as the wave travels through silicon. Which basically, the way that it's doing it is through interaction and transfer of energy from electrons that flow to the phonons that create the vibration in the material. It's an amazing phenomenon. Like how it works, it's just every time I think about it or see it on one of these instruments that we have in the lab, it just puts a smile on my face. So that's the kind of thing that I want to do more if I get a chance.
That's incredible.
And then,
that
and then
awesome.
the same is true about photons too. Like photons also interact with electrons and phonons at those scales. So.
That's really awesome. And you spoke about, leaving a legacy. And although that idea, you said comes with age, I think it's also important for everyone to remember that, we do have a legacy. People we interact with, through the things we leave behind. And I think it's a good lesson for everyone to hold on to is, find those things you're passionate about, find those things you care about. It's nerdy, who cares if it's, if it puts a face or if it can make this world better. Like, that's part of who you are, and the ways that you create are going to extend to other people, and the things you care about will do that as well.
Absolutely. Yeah. I certainly agree with you.
So, following from this, aside from your wife, your research, and your love of circuits, what else puts a smile on your face?
Kids.
like kids?
Kids. I love interacting with my son and my daughter. If you want to ask me what was the most important, like what happened in your life that it was the most dramatic shift in your understanding of life, was when I was blessed with my kids, like when they were born. Like that, like my firstborn, I never forget that. That just completely changed me in many different ways. It is, I can't tell you how much of a different person I've become. Not like you don't necessarily see it in terms of how I behave, not necessarily, but it definitely changed me in how I see things, like how, in terms of priorities, for example, what's important, what's not. I became a different person.
Oh yeah, my sister actually now has a 9-month-old, and I've seen that same thing in her as well. Like it seems like there's something, and obviously I don't quite understand. I don't have kids of my own, but there's something certainly life-changing and perspective shifting about having not only a whole new life added to yours, but something that's now your responsibility. And like you said earlier, responsibility makes you grow.
Absolutely. There's definitely some of that in terms of how it impacts you. The responsibility is definitely part of that territory and impact that the kid has on you. But I think there's some biological changes that happen in you too that you're not even aware of. Like there's things that happen biochemically in you that just they're not in your control.
That's incredible.
Evolutionary.
Do you think there might be another shift in you when your kids have kids?
Oh,
I'm sure that's going to be. I don't think it's going to be the same kind of experience, but it would be. I can see how that could be very joyful and impactful too. But it's. I wouldn't put it on par with what I had in terms of my own kids.
No, of course.
It's a different kind of joy. I think it's going to be a different kind of joy. And usually you don't compare things that are necessarily that different.
Yeah.
Hard to life experiences, It's hard to make those comparisons.
Yeah.
Do you think that your kids impacted the way that you see engineering problems as well?
I definitely think that the kids changed the way that I function in my interactions with everything, including engineering problems, because it changed my priorities, right?
Yeah.
I'm sure it has, and I think it had made me, generally speaking, a better person, I think. Let me put it this way, in terms of, okay, so because they say engineers are good with things, right? Like we're not necessarily good if like people that are engineering minded, right? We're good with things, but we're not necessarily good with people. Like
Yeah.
sometimes we lack in that domain.
Yeah.
I think I have grown to become more appreciative of the human aspect of life as opposed to just dealing with things. So
That's incredible.
yeah.
That's incredible, and that's so sweet.
Yeah.
You know, I find it interesting you say that because some classmates I have are very good with things, but not good with people. And it's just funny how that's how engineers operate. You know.
Yeah. I mean, it's actually, I think it's quite a known thing that people that are good with things are generally better engineers. And again, I'm not valuing anything here. It's just that's how things are.
No,
Oh,
of
yeah.
course.
Yeah.
Oh yeah.
It would be a really, really boring world if everyone was an engineer. Definitely.
Oh yeah. I mean, like you said, you're not valuing anything. It's on one hand, it is good to be good at solving things, but this world is also full of people. We need to work with both here.
Yeah, life is a lot more fun and complex than just dealing with things.
Yeah. Definitely makes it interesting.
If anything, I think
And so kids made me more appreciate that more. Let's put it that way.
well, that's really sweet. I think it's really interesting. Like our whole conversation has been very eye-opening because I know when I was younger, like first grade, second grade, I had this weird thought that teachers would just live in a school. You know, they weren't people too. And I think that's a really important message we want to send out. Like, you're a professor, but you're also a father. You also do research. You're also an engineer. You're multiple things, and that's really awesome.
Right?
Oh, yeah.
Thank you for the opportunity for me to actually be those things too. Let the people know that I'm not just a circuit analyzer.
Oh yeah, and that's what we want with this podcast. And I'm so happy that you were our first guest because you really accentuated the fact that more than a professor, you're a father, you're a husband. I mean, you have your life. And although I'd like to think a lot of people at this point in our lives recognize that, it's definitely good to put it out there and
Yeah.
get a peek behind the curtain.
Now you'll be very surprised how people are still like afraid of even talking to professors. You know, going to office hours, reaching out for help.
Oh yeah. So now that you brought that up, so I was going to say this at some point during this interview. One thing that to my experience, has been really good with the virtual teaching is that the number of questions that I get from students have increased by a lot. Like people, especially in office hours, they feel a lot more confident in asking questions. And I asked people, like I asked the students, okay, so I feel there's a shift. Like I get a lot more people joining office hours first of all, and then when they join, they ask more questions a lot more freely. What is the difference? How come you ask questions now and before no one would show up in my office hours and there was no questions and everything? And some of the answers make sense. So they say the fact that you don't see us actually is helpful. Like if you turn your video off and you ask a question, that anonymity helps people. Like just you feel more relaxed. I'm not being judged, I guess.
Yeah.
Like they're not those watchful eyes looking for every mistake that I make. So I feel more protected, and I can just ask.
From a student's perspective, this is really dumb to say, but I just don't want to seem dumb in front of my professor, you know?
Oh yeah.
I want to show off that I know how to do this, but like,
yeah.
same time, please help me.
But one thing I have to say, and this is a very natural thing for all of us. We all have it. But one thing that I can tell you, and I've said that to other students, and I'm going to repeat this in this medium so that maybe I reach more people through your podcast, is that one of the things that I learned by living long enough is that a sign of growth as a person, but also as someone who does engineering and science, is that I have to put myself in a position to be judged by other people. It's completely like, that's a risk. That's a risk that I have to take, and it's scary. It is scary. Being judged by other people is scary. I'm not denying that. I'm just saying we have to take that risk, and we have to do it, because through that I'm gonna grow. By letting other people see the flaws in me, and hopefully maybe pointing them out to me, I grow. And so there are two, and the way I advocate this is like this. Let's say you do have a flaw, right? Let's assume that you do have a flaw. You have two options. You hide it, and you will never fix it. You don't hide it. People make fun of you. I'm just
of course,
exaggerating it, but pointing it out to you. Let's put it that way, and then you fix it. Which one is better? Now it's painful. That process of being judged by other people, they point it out to you, and maybe in cases they're not gonna be very friendly. Like maybe they're not gonna be very friendly. So it might be quite painful. But what's the outcome? I'm gonna come out without that flaw, hopefully, right?
No, yeah, of course.
So if that's the outcome, the price is completely justified. Like the price that I pay in terms of putting myself up for criticism is justified. It's all right. Like I'm fine with you criticizing me. That's why I actually solicit feedback, because I know for a fact that every time that you say, "Oh, you did this and I didn't like it," it's gonna hurt. Like it will hurt. Like when you say, you do these things this way and that's stupid. Like, why are you doing it this way? And at that moment, it's gonna hurt. But I'm fine with that. That's the price that I'm willing to pay. The pain is fine, because then I'll think about that, whatever that said. And it's not necessarily that what you said is correct. In cases, maybe you're not correct. But there are things from that experience that I can learn and become a better person. So that's all I wanted to say. Is that, yeah, it's all right if it helps you and you don't see, like you felt more comfortable with the anonymity and you like it, go for it. It's good. And I'm going to provide that medium for everyone to take advantage of. But I think it's even better if you turn on the video and you say, "This is me, criticize me."
It sounds scary, but I think especially, coming from the professor's perspective and the fact that your position is scary as well. Like it creates a sense of just humanizing nature between the student and the professor.
Yeah.
I think it's important to
so
really
one
log
thing
what
that
you
I
just said.
do, Brian, that I think it's useful, and I don't know if it has been noticed by students or appreciated as much as I want it to be. Maybe I need to advertise it more. Is that I come to class and I say, "Do you have questions?" Every time that I come to class, that's what I do. And then those questions, I'm taking a risk, because there's a really good opportunity, there's a really good chance that the question that you're going to ask me, I don't know the answer to it. I'm not going to shy away from it. If you ask me a question that I don't know, I'm going to say, "I don't know. I don't know the answer." And then that's not fun. Like as a teacher, it's not a good feeling to go in as someone that is supposed to know the answers, and then you ask that person a question and he or she doesn't know the answer, right? But I'm fine with that, because I want you to see me fail. Like, I'm completely fine with that. I fail too. And the other thing is that you ask me a question, I start doing it, and that's very common in me making mistakes. And every time that I'm making a mistake and people point it out to me, I've failed right there. And then, like, you can see me in bright lights how imperfect I am.
Yep.
How I easily make mistakes. And I want you to see that. It's all right. I make mistakes too.
I never really thought about that, to be completely honest. Because, again, we all put, like, teachers at such a high pedestal. But at the end of the day, you know, we're all human and we all make mistakes. And that's really comforting in a way, really.
Yeah,
So
it's
I
also
hope
important.
that people see that and get comfortable with the concept of failure.
Yeah.
All right.
One of our most powerful tools is failure. Yeah. I guess going back then, to the acoustic resonance was, in my head, mine not ready for that conversation. But that's what you would enjoy doing with the extra liberties given in your life.
Yes. So
What are you doing now that you enjoy?
So let me tell you a little bit about what I do, generally speaking, and what fascinates me generally in terms of the kind of research that I do. So I always kind of characterize my research as the intersection between electrical engineering and mechanical engineering. So it has a terminology that I don't think necessarily captures everything that I do, but it's close enough. It's called micro-electro-mechanical systems. So you see all these buzzwords: micro meaning the small things, and then electro, well, things related to electrical engineering, and then mechanical, things related to mechanical, and systems. So it's just the system of things. So it has all the components of what I do in a sense. So they're basically these really small devices where, for the most part, they are mechanically moving, but then they interface with electronics. So they move, but also interface electronics. So if you want examples on a macro scale, so that you can kind of get an idea, like think of, I don't know, an electrical motor, right? So the energy delivered to the motor is in the electrical domain, but you create a mechanical action, so something moves. So now you can scale the same thing, and then you can make a micro-electro-mechanical motor, like something that just does the same thing, but at a much lower scale. But then if I want to go one level lower, maybe, and that's the level that I'm more comfortable in terms of describing things, at least to myself, is at the level of physics and energy, right? So my research is kind of at the intersect of different energy domains, like how the energy goes from one domain to the other, and how can you control that process. Because really, engineering, one way to describe what we do as engineers is that we pay a lot of attention to how energy moves from one domain to the other, and try to control that process and make useful things out of that. Like, you can actually, that's a pretty good description for a lot of things that we engineers do. We just love to control energy and the transformation of it, like how it goes from one thing to the other. We love to get, like, we're control freaks in the domain of energy, right? Like, we would love to be able to completely control energy. And
When you're talking at such a small level, are we talking like energy mass conversion, or are we still talking about like electrical to mechanical conversion?
I mean all the different ways that energy can go from one domain to the other, but not necessarily, like, when you say energy mass conversion, you're talking about the like nuclear kind of energy.
Yeah.
That's not what I'm talking about. At least
Okay.
that's not the level of energy conversion. I meant different kind, like energy transformation from one domain to the other of the energy itself, not from mass to energy.
I
or
see.
the other way
Okay.
around. Like, for example, like if you shrink it down to the units of energy, and that goes back to the kind of discussion that I briefly had with you. Like in the domain of electrical, we work with electrons a lot as the charge carriers. And then in the domain of mechanical, movement, stress, strain, displacement, and the unit for mechanical energy, like elastic energy, is a phonon. And then in the domain of high frequency electromagnetics, then the unit for energy is a phonon. And these different quantum particles, they actually interact with each other, and they transfer energy from one kind of particle to the other. And all through that transformation, if you can control that process, you can go from one domain to the other and do something useful, right? So mechanical resonators, again, if you're dealing with electromechanical resonators, is one of those examples where you apply electrical energy in the form of charge and current, and then what you gain on the other side is actually mechanical movement, a mechanical resonance. And there are certain applications that really require that kind of energy transformation. Resonators have a lot, mechanical resonators have a lot of applications in day-to-day life. An example that comes always easy to relate to is the kind of resonators that you have, you say, in your cell phone, your smartphones. Like there are at least 5 to 10 mechanical resonators in every smartphone. Most likely you don't know about them because you haven't exposed to that domain, but I can't think of any electronic device that doesn't have a mechanical component in it. Especially these days, with all the sensors that are, like anything that you call smart has some sort of a sensor or actuator in it. And with those comes a lot of mechanical movement and transformation of energy from mechanical domain to electrical domain. And that's where I do a lot of my research, generally speaking. There's this quotation from Nikola Tesla that I put it on my wall, and I'm going to show it to everyone now that you gave me an opportunity, because this basically describes my view of the world, the nerdy view of the world. I don't know if you can read this. Can you read this?
If you want to, you got this, Fern.
Go ahead, King. I don't have my glasses.
Oh, if you want to find the streets of the universe, think in terms of energy, frequency, and vibration. I like that. That's from Nikola Tesla.
Yes. If you want to find the secrets of the
Oh,
universe.
secrets.
Oh, the streets.
Think in terms of energy, frequency, and vibration. And the more I have known about science and physics, the more I found how genius this guy has been.
Yeah.
Like to say that kind of a statement like more than 100 years ago, that says something about the genius of that person.
Oh yeah, I didn't even think about that yet.
Because the best models of the universe today, they actually tell you that everything that you see, feel, hear in the world around you could be described as a vibration in an energy field. That's it. That's everything around you. Everything is a vibration in a field. Everything. That's the most, and I'm not saying that's necessarily how things are. This is the best we know today.
Yeah.
Is that everything around you, the building block of universe is vibration in fields. That's it. That includes all the energy, all the matter, everything that you see or don't see.
That's awesome.
That's basically what he said.
And especially as engineers, our goal is to replicate and understand everything we can at whatever level we can. And knowing that, I think, is definitely a good step forward.
So yes, vibration is my passion. In a sense, I I'm trying to understand the secrets of universe.
That's crazy.
Definitely, a wonderful path ahead, and I assume quite a wonderful path being left. Well,
Sure.
well, all right. So I believe that's about all the time we have for now. Dr. Reza, is there any last minute comment to make before we get going?
Just want to again thank you for the opportunity. I really appreciate it, and I definitely like to do this. I enjoyed it. Anything else I can think of? Well, I would like for everyone at UCF to think about their experience at UCF and be more proactive. That's one thing that I wanted to let everyone know. I think there are things that we can, giving back, like we can all start thinking about how we can give back and let the community that we have grow as a unit, like by actively thinking about how we can help each other. So examples are the things that you're doing right now. This thing is an amazing thing that you've started. And you're taking time out of your personal time, things that you could have done just for yourself, but you're trying to create something that is useful for others. And I think we can all learn from that. We can all think about what you're doing and try to do more of the thing that you're trying to accomplish here. And there are a lot of opportunities for that. Just get involved, like in different ways, different ways of getting involved. And there are so many opportunities that you can do that. For example, just as simple as giving feedback to people that are doing things, right? Like there's a structure in the university. If you don't like something, speak up. Become part of a movement. Like if you think that UCF is not doing something properly, then get together with like-minded people. Go talk to people who can make changes. Like go make sure you're heard. That's how a unit structure, an institution grows. The growth has to come from you, from the bottom. So that's all I wanted to say.
And
Those are some wise words.
That's a beautiful message.
Wise words, and thank you so much for your support for this program as well.
Let
Hopefully
me know if I can be of any help in the future.
No, of course. Hopefully you're back for season 2.
Yep. Definitely love to have you again, and yeah,
Sure.
Thank you so much for joining us.
Thank you so much.
Maybe next time we can talk more about, I don't know, maybe just classes and electrical circuits and maybe more technical.
Oh, absolutely.
Yes. Yeah.
Tutor us next time. All right, and cut.